Good morning, guys. My name is P. Hudaya Sankar. I am from CSE section. Today we will talk about a subject of advanced data structure and algorithm analysis, and the topic is client decision problem, and it is known as CDP. The clue decision problem. The clue decision problem is a fundamental problem in graph theory that involves identifying the largest screens or fully connected subgraphs within a given network. This has important application fields like social networking analysis, bioinformatics, and computer science. And the clean is a subgraph of this graph. It is the connected graph which is fully connected in the graph of a subgraph. Introduction to graph theory. Graph and vertices. Graphs are mathematical structures composed of vertices and edges, and it is also known as connections between them. Adjacent, Adjacency and connectivity. Vertices that share an edge are considered adjacent, and a clue is a subset of vertices where all pairs are adjacent. And now we will talk about the graph algorithm. Graph algorithm is a solving graph problems often requires specialized algorithms to efficient traversal analysis and optimize network structure, which is known as the graph theory is very useful, and it requires specialized algorithms to effectively traversal, which is display, and it's analyzed very fast and quickly and optimize network structures. Defining the clue decision problems. In the decision problems, there are four types. First one is question, second one is input, and third one is challenge, and fourth one is goal. And now the input is a graph G and an integer K. There are two types. In that, the graph is known as G, and the completed graph is known as K. And now the question is, does G contain a clue of size K or greater? Yes, it is. Yes, the G is contain a clue of size K, and it is greater. If the graph is having a four connected graph or five connected graph, but the clue size of the subgraph is lesser, I think, lesser. So the G contains a clue of size K. And now the challenge is, the problem is NP complete, meaning no efficient algorithm is known to solve. Here the challenge is, the problem is NP complete, so the problem is NP hard, meaning of no efficient algorithm is known to solve it. And now the goal is, determine whether such a clue exists in the given graph. And now we having the goal to determine which the graph is a clue decision problem or a normal graph. Brutal force approach. Generate all subset, enumerate all possible subset of vertices in the graph. In the brutal force approach, it generates all the subsets which is enumerated all possible subsets of vertices in the graph. Which means in the graph there are subset of vertices which possibly all are enumerated. Check for clues. For each subset, verify if all vertices are pairwise adjacent. And now we have to check the clues which has in subset. We have to verify the all vertices which are pairwise adjacent. That means the subsets are adjacent or not, which are pairwise. Return result. Report the largest clue found, or indicates no clue of size K or greater exists, which means Return result means in the subset in the graph there are number of subsets, and the number of subsets having the number of clues, uh, and the return result means report the largest clue found or indicate no clue of size k or greater exist means uh, it will report the largest clue which is found in the graph or in the subset, or indicates it having it does not having any clue of size k or greater exist, which means it is having the size k or greater exist. Efficient algorithms for client decision clue decision. There are three types. First one is born Cremosan algorithm, and the second one is Tsukushima's algorithm, and the third one is approximation algorithms. These are the three types of the algorithms. First of all, we will talk about the born Cremosan algorithms. It is a recursive backtracking algorithm that efficiently enumerates all maximal clients. It is an algorithm which is used a recursive backtracking algorithm which is useful in the daily life to backtrack the problems, and that is efficiently enumerates all maximal clients, which means this algorithm which is effectively enumerates all maximal clients, which is known as born Crevosan algorithm. And Tsukushima algorithm, an algorithm that uses a clear data structure to find all maximum clues in the polynomial time. This algorithm it is also very useful, and it uses the clever data, which means it is very clearly at the data structure to find all the maximal clients which is present in the subset of the graph in the polynomial time, which is means polynomial means which is 5 in the polynomial time. And the approximates algorithm techniques that provide providably good approximate solution with when an exact solution is intractable. It is the approximate algorithm which uses the techniques that provides a good approximate solution when an solution is intractable, which means when an exact solution is founded, the approximate algorithm will take it and give it to this user. Complex analysis and practical consideration. There are three. First one is computational complexity, and the second one is heuristic and trade-offs, and third one is real-world constraints. We will talk about the computational complexity. The client decision problem is NP complete, meaning there is no known efficient algorithm to solve it. The computational complexity is which is NP complete, meaning there is no effective algorithm to solve it. Heuristics and the trade-offs. In practice, researchers use a variety of techniques to balance speed and accuracy for specific application. It is used in the researchers like scientists. They use a variety technique to implement the balance of the speed and accuracy for specific applications, which means there are specific applications in labs and scientists which are uses it has in the specific applications. So they use this algorithm, this one, history and trade-offs. Real-world constraints. Factors like graph size, density, and application domain can significantly impact the effectiveness of client decision detection algorithm. The real-world constraints, which means the factors like graph size, density, and application domain, can have a very large impact for the client clue decision algorithms. And real-world application of client decision problem. We can see in three domains. First one is social network analysis, and second one is mathematics, second one is computer science. In social network analysis, identifying tightly knit communicates and influently groups with social networks, which is it is used very useful in the social network analysis, which influence groups within the social networks. And bioinformatics, discovering protein complex and the regulator modules from biological interaction data, which is very useful in the bioinformatics, which is used in the biological interaction data. And third one is computer science. Optimize resource allocation, rotating and scheduling problematic modeling as a graph, which is used for the optimize the resolution of the algorithm, rotating and schedule problemming in the model as a graph. This is about the few decision problems. So thank you.